That is point A, that is point B, and that is point C. Okay. So here I have taken these points A, B, C. These points A, B, C. Now here check points A and C. Now segment joining this A and C is neither parallel to x-axis nor parallel to y-axis. Still I want to find out distance AC. For that, first of all, A having coordinates -1, 2. Okay. Point B having coordinates x coordinate 3, y coordinate 2. Then point C is there. Point C. Here x coordinate 3, y coordinate also 3. Here we got coordinates of the point. Now I want to find out this distance AC, this distance. Here we cannot find out distance AC directly. So first of all, consider this AB. This AB. Now this AB is parallel to x-axis. Okay. Now AB parallel to x-axis. When a segment is parallel to x-axis, then distance between that point is equal to difference between their x coordinate, provided x2 greater than x1, that means x2 minus x1. So here if I consider formula x2 minus x1 where x2 is greater than x1, that provided. Okay, so that is x1 y1, x2 y2. So here if I consider this x1 y1 and that is x2 y2. So from this x2 minus x1, so what is x2? That is 3. What is x1? Minus 1. So here 3 minus 1. 3 minus 1 plus. So here therefore distance AB is equal to 4. We got this distance AB. This distance AB is equal to 4. In the same way, now let's find out this distance BC. Here I consider x3 y3. x3 y3. Okay. Now BC is parallel to y-axis. You can check that. BC is parallel to y-axis. So if it is parallel to y-axis, then distance BC. When a line is parallel to y-axis, then distance between the point is equal to y2 minus y1, where y2 is greater than y1. And if y1 is greater, in that case, y1 minus y2, provided y1 greater than y2. y1 greater than y2. So here, check here. Now here, in first case, we have taken general formula x2 minus x1, or here I have 3 points. x1, y1, x2, y2, x3, y3. Now we are considering these 2 points. So for this I have taken x2, y2, and for this I have taken x3, y3. So here we have to modify formula. So here that will be y3 minus y2, provided y3 is greater than y2. So here put down value of y3, that is 3, y coordinate minus y2, check y2, that is 2. So here distance BC is equal to 1. We got this distance BC is equal to 1. But still our answer is not complete. Our question is find distance AC. We want to find out this distance AC. As you can observe, it is parallel. They are perpendicular, so obviously it is a perpendicular. Perpendiculars drawn on the same line are parallel to each other, so they are perpendicular. So here we got right angle triangle. So here in triangle ABC by Pythagoras theorem. By Pythagoras theorem. What will be your formula when you are point A? So here using Pythagoras theorem, AC square is equal to BC square plus AB square. Let's put down value. 1 square plus 4 square, that is 1 plus 16. So here AC square equal to 70, and then by taking square root, AC equal to, here we cannot find out square root, so square root of 70. So in this way you can find out by using Pythagoras theorem. But as it is quite difficult to us to find distance between any two points when the point lies anywhere on the Cartesian graph system, every time we cannot use the Pythagoras theorem. Every time we cannot use the Pythagoras theorem to find out distance between these points. So in that case, we have another formula how we can find out distance between these 2 points. Now consider this point A and C. C 3 and A -1 2. These are the coordinates. Okay. Now I want to find out distance AC. Whenever you want to find out distance between these 2 points, when these points lie on the Cartesian graph system anywhere, for that distance AC or AC equal to square root of here in bracket provide x2 minus x1 bracket square plus y2 minus y1 bracket square. That is the formula. So whenever you are given such point, use this formula, you can find out distance directly without finding separate distances and without using Pythagoras theorem. So here let's find out whether our calculation is correct or not. When we solve it by using Pythagoras theorem, we got this answer, square root of 70. Now using this, here I have taken x1 y1 and I have taken this x3 y3. So here I have to modify. So here instead of x2 I will use x3 and here y3. Okay. x3 minus x1 bracket square plus y3 minus y1 bracket square. Let's put down value. x3 3 minus x1 again minus 1 bracket square plus y3 again 3 minus y1 2 bracket square root of this 3 minus minus plus 1 bracket square plus 3 minus 2, that is 1 bracket square. So square root of 4 square plus 1 square. So AC equal to 60 plus 1. Therefore AC equal to square root of 70. We got the same answer. That means without using Pythagoras theorem, without performing too much lengthy calculation, we can directly find out distance between any 2 points. Now this x2, x3, x1, that you have to modify according to your condition. Generally only 2 points, you can use x1, y1, x2, y2. If more than these points, then x3, y3 and so on. So purposefully we will use that, and using this we will find out the distances. Okay. So here using such formula, sometimes instead of using square root sign, now here I use square root sign, you can use this one also. AC square equal to x2 minus x1 bracket square plus y2 minus y1 bracket square also. If you don't want to use square root sign, then you can avoid by taking square, and here avoiding square root sign. Use this one or AC equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Both formulas are same. We have to use it accordingly. Okay. Now based on these formulae, let's start practice set 5.1. There are so many questions and then one by one we will study all that.